Yeah, hi. Happy Equinox Day, everyone. We had nice weather today, even though I couldn't really spend it outside, but I saw it. The sun was shining, moon was shining, 20 degrees below zero. Uh, so let's continue with the topic of ice.
How do glaciers shape the landscape? Glaciers are frozen rivers of ice which have immense power. Glaciers are so powerful they can carve huge chunks out of mountains as they flow downhill. This makes them one of the most powerful natural tools on our planet. Glaciers are sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in three ways. Firstly, glaciers pick up material. We call this erosion. Water flowing along the bottom of the glacier seeps down into the rock below. When it freezes, it opens up the cracks in the rock. This is known as freeze-thaw weathering. Then, as the glacier flows downhill, pieces of rock come loose and the glacier pulls them along with it. We call this plucking. Ouch! These rocks and stones scrape along the glacier bed like sandpaper, taking more rocks and stones along for the ride. This is called abrasion. Secondly, the glacier transports this eroded material as it flows downhill. Some of it is hidden inside or at the base of the glacier where it can't be seen, but sometimes it is transported on the top of the glacier. This is why glaciers often look dirty. As the glacier flows down a mountain, it gets warmer and starts to melt. Just like a snowman, anything which cannot melt is left behind. As the glacier melts, the rocks and stones fall to the ground. We call this deposition. By now, this material is a tasty mixture of rocks, stones, sand, and clay, known as glacial till. The melted ice turns into meltwater and flows downhill to join a river or lake. Today, glaciers only exist in the coldest parts of our planet. But during the last ice age, glaciers existed in the UK too. Although the ice has melted, they have left behind some awesome scenery. As our planet warms up, many of our amazing glaciers are melting fast. So grab your walking boots and head to your nearest glacier while there's still time to see nature's bulldozer in action.
Oxford University Press. Uh, let's check out something else. Or it's actually about glaciers too. That's a screenshot I took yesterday. I couldn't make a video, so I just took a screenshot. Bevertenstock, Glarner Alpen, Switzerland. Here is, sorry, a little bit zoomed in. The an earthquake on top of a mountain. Depth under the epicenter, 2 kilometers. Which maybe indicates it's in the mountain itself. It's not of the, how to put it, landscape surface on which on top the mountains are, if you get what I mean. It's inside the mountain. So now let's check out this place a little bit on Google Earth. Here we have it. Bevertenstock. I guess it's summer there. Otherwise, there would be much more snow, I guess. But the geology is really interesting. For example, we have these really nice separation of sediments. Different colored rocks here and here on top, and here it gets even darker. Yeah, I didn't knew that there's any pictures of that. Yeah, I just started to make a video like always, no script or whatever. So, whoa, that's really cool. I want to see a glacier doing these kind of things. Or a volcano. That's really amazing. Yeah, two pictures. They were really cool. Thank you, Google. So now we are in the Alps. And there is a lake. There's actually many lakes there. And if you watch like this landscape, like for example here, what we have seen just before in the picture. Can I? I can't. If you watch at that geological feature here, here's like this kind of bowls on that side, and here it's a really steep creek. So I guess this mountain is really, yeah, now it works, finally. That's a really sharp edge of a mountain. Whoa, that's really sketchy to use Google like that. Google Earth sometimes. I want to get back to the possibility to see it from above, but wait a second. No. So, the quake was somewhere here, I guess. And if you watch at like some other features, what we have here, first of all, it's all really steep. And here we have a glacier still running down, which starts really on top of a mountain. And somehow, as far as I know, if you go up to the mountains, and I have been there many times, that's why I say I know, because I have been there. I haven't read it in a book, I experienced it by myself. It's windy up there, you know, really windy. Somehow it's really hard to grasp for me that there would be just on top of mountains accumulate that much snow in such windy conditions. So, since I pondered about this glacier thing, and I, in a way, never really could wrap my head around that it's just the accumulation of snow which creates the glaciers. And second, that they are working like a bulldozer. Let's go quickly back to the video. Somewhere here it's coming.
Powerful natural tools on our planet. Glaciers.
So now she's talking about the bulldozer. What is happening with this dirt which he's pushing into that direction? Let's have a look.
Are sometimes called nature's bulldozer. Just like a bulldozer, glaciers shape the land in
What happened? There's a pile of it. Okay. There's a glacier. melting through climate change. Which is carving the valley, probably at the moment we speak. So now, what I'm trying to do is to find the pile. Where is the pile? This glacier carved out over millions of years. Really deep valleys. There's even a picture from down below of the valley. Yeah, check it out. This is actually Lindschlucht, it said before. Lind is a river which flows through Switzerland. It flows into the Lake of Zurich. Afterwards, it's another named river. It's Limmat. And as it flows on, it goes into the river Rhine. And as it goes on, it goes through Germany. It's the border river between France and Germany. It goes through, was it Netherlands or something, and then goes into the sea. And the Rhine Valley, close to Switzerland, we have volcanic activity. There is a volcano, and more upper north, we have the Lachersee and Koblenz, where we had the floods and stuff in summer. And that's the place somehow where it all starts, the river. So now, as I just explained in this Oxford video, this valley, all the valleys here, everything that you see which is missing, got once carved out by a glacier. Nature's bulldozer. Now, that's a good picture. My question is, where's the pile? Where is it? I just found something really interesting. What the food? What? Does anyone knows about that? I am speechless. Whoa! I want to go there. Maybe I got to arrange something. There's water pouring out of the rock. So, my theory, I have to a little bit hurry up. This is representing this kind of electrical discharge. It may come from above, like, let's say, heaven. Atmospheric. It might be atmospheric in origin, or it could be a continental arc discharge event, which wouldn't be that atmospheric because it's somehow ground to ground discharge. But anyway. Yeah, that's a really exciting find. And I thought about, since I'm exploring the electric universe, and have been living in Switzerland and have been in the Alps many times and read about glaciers and how the Alps perform and all this kind of stuff. I got teach that stuff in school. So I'm sharing my paradigm shift in thought about creation of stuff with you. I'm learning by doing. And my theory nowadays, or how I think, what would make much more sense to me is that we have this kind of electric discharge event, which is somehow, how to put it, positive, which means if that's ground material, whatever it is, dust, former mountains or whatever, through that electrical discharge event, we get the dendritical patterns. It gets sucked up electromagnetically and also through winds, probably, which gathers the material there, but it gets fused together through electrical forces. And since we have groundwater almost everywhere on Earth, there's a layer of water beneath us. And now I will paint this green stuff is the water, which works really good as a conductor, and it's penetrating like many things, like really like if things are wet, there's water everywhere. So it's connecting things. And since we are talking about connections and electrical discharges, and we have water, which may include many minerals and these kind of things, it will help to make the connection above from below. Yeah, you can't really see it. And the electricity will go down there. And that's just the result, which how the mountains were grown upwards to the heavens electromagnetically, and water played the important role because it probably made this kind of really, really good connection between the soil and stuff. That's why we find many wells and springs and stuff really high up on the mountains, even sometimes almost on mountain tops. That's a really fascinating picture. What? Yeah, I have been in these kind of sceneries. I know how it feels to be in this kind of valley, but I haven't seen this kind of rocks which are pouring water out. Here is it again. What? And many of those dwells up high in the mountains, they probably don't function anymore, so to say, because like since they got created 12,000 years ago or something, some minor earthquake or whatever, like if there's a crack in the rock, the vein is like damaged, probably doesn't work anymore. There are many which don't work, and some are still working, and the biggest of those are the ones which we find here. The start of a glacier might be a well. Here's probably water coming out up from the ground. Still connected to the groundwater, there could be found probably some interesting mineral or conductivity anomalies or what have you in this water if they would somehow would look out for those. That's why they are somehow like, how to say, flowing those glaciers. Yeah, but I leave it here. I ran out of time. Thanks. Bye.